Hello guys, this is Mayank Chavda with Team MICROHUB here. So today we are going to demonstrate this particular test fixture in front of you. This test fixture is very unique because we have connected lots of different types of peripherals with this test fixture. This test fixture has a power pin, BAD and PLC and HMI system and taking automatic connections with the load condition, no load condition, lots of different types of things inside. So let me give you a brief about this test system and let's start today's video. So this is the PCB on which for which we have made the particular this test fixer. This particular PCB is working for the street light charging purpose. So client requirement is to test this particular PCB with different types of test conditions like with the load current, no load current, with the when this circuit is working on the battery, what is the status of the battery charging is done or not, battery charging indication is working or not. If battery is not available, means if main supplies are available, system is working with the main supply or not. If it is not available, it is going to shift on to the battery or not. So lots of different types of test conditions are there, which are included into this particular test fixture, and we are testing this PC with automatic test conditions as well as we are measuring all the currents and lots of other parameters to validate this particular PCB. Yeah, so if you have any such kind of requirements, please call MICROHUB. So we'll get back to you with these type of solutions. So this particular circuitry is going to be automatically connected with the external peripheral like power supply. We have utilized the GW Instack power supply here. This is a programmable power supply, and we are using and controlling this programmable power supply using this particular HMI and PLC based systems. So whenever a charging current, we want to increase the voltages, like solar panel is going to increase the voltage from morning to afternoon. So whenever the power supply is going to increase, what this particular circuitry is going to work and how it is going to perform will increase this type of power from this fixer to this particular, will give the command to this particular power supply, will get that power input to this PCB and will validate the performance of this type of this PCB. So yeah, we have introduced this power supply with this fixer, and is going to be connected with the USB here. You can see we have connected with the USB here, and is going to the PLC unit. I will also open this fixer at the end of this video, so you will get an idea. You can see a structure of micro. We always say this. We are providing a rigid structure here. You can see a cavity based system here. You can also see a 4 linear rod with 12 linear bearings, like 4 upside, 4 in middle, 4 in downside. So there is no any misalignment issues. There won't be any there, and it is going to be a rugged and it is going to be a very rugged systems to utilize. So we have in-house mechanical tool room for this type of drilling, cutting, and CNC and VMC workouts. We have in-house electrical, mechanical, and mechatronics team members who is performing, who is doing the programming, as well as doing the inside panel wiring, paneling things, and doing lots of different types of variety of jobs to perform to complete this type of test fixture. So we'll get a one-stop solution from MICROHUB. So let's start a practical demo. Just user. So to validate this type of PCB, like to validate this type of 15 to 20 conditions, how you are going to validate? You will manually attach the wires here. You will manually change the power. You will manually do lots of things. So it will take approximate 60 minutes of time to validate this PCB. And you also know how to how when performing this type of task, there we require lots of accuracy and repeat, there won't be any repeatability. So using this type of fixture within a fraction of seconds, you will get an validation of this type of PCBA. So per day production is going to be increased from your side. Also we'll get the analysis, we'll get the data logging inside that, that how voltage and how current is performing, or lots of data is required. We'll have the timestamp data logging with this timestamp here. So yeah, this types of fixture is very utilized for the production lines. This type of fixture is utilized for the R&D purpose, and it is also utilized for the prototyping purpose. So even if you are in whatever you stage, you can contact Micro. We can provide this type of fixtures to you. So let's start a practical demo on that. We'll just user need to put this type of PCBs here. We'll just give you the pressing here. So all the connection is going to be connected through the POGO pin with the uh, particular power supply with the load. Like we have attached one LED here. We have attached one battery here. So automatically connections are going on. Also, if require programming, you can see a DB9 connector here. So is user easily do the programming part. Even if they want to change, they can check it out. So you can see a particular window where we have entered the 5 volt. So if I want to change the voltage here, just need to enter here. You can see in power supply there will be a 5 volt. Now if I entering that, you can see a 11 volt of power supply. So here very easy to change the power supply also. Fixer is particularly performing this type of task automatically. So this is the for the manually entry, but whenever it is required automatically, the auto generated program will change the power supply accordingly, and it is going to give the this type of condition to this PCB and will validate that voltage or current or what charging things are going perfectly or not. So let's start. Just user need to check. So in this PCB there are two type of tests: test one and test two. Test one is for the load, no load current, and another parts. Test two is having also another uh, different types of tasks. So we have categorized into tests but to test this particular PCB in two different types of test conditions. So let's start test one first. So I'll just press test start, test one start, and we'll start the button. You can see a pass fail conditions here. It is going to read the current. It is going to give the delays is as required. It is going to check the current. This current is going to be checked here for the 100 times. 100 times you are going to check the current, that this current is perfectly giving the output or not, we are getting the perfect output or not. So you can see this all the conditions: initial current, red LED, green LED. We have attached one red LED and green LED also here. When red LED is on, we are measuring the current. The current is going we are getting output or not, so current is increasing or not. So green LED also we are validating. This particular PCB is going to be connected with this type of LEDs. So we are testing that LEDs are working or not through the current. Also, load current is okay. Battery low cut off is okay, and battery reconnection is also okay. So test one is perfectly executed and it is going to be passed. So you can see how much time this system takes to test this PCBA. And if we do this type of manual task, it is going to take lots of time. So now let's perform the test 2. Also settings for the test 1. If I want to test, if I want to do some settings, let me reset this. So if I want to set some voltage, some tolerance, some time delay, we can easily set these type of things through this fixture only. So this is very dynamic system we have provided to the client, and we are also always providing this type of dynamic system, so we can change it automatically. So let's start test 2, and we'll start this. You can see a LED is working or not, it is going to check it out. So both LEDs are working or not. You can see read current with the charging okay or not okay, and step delay. So it is taking lots of readings here, and it is going to give the output accordingly. So you can see test 2 is not okay because charging is not okay. So as I said, we have connected battery with this type of banana pins. With this type of banana pins, we are taking the we are connecting the loads. So battery charging is not as per the requirement. So yeah, you can see within a fraction of second, we can get the perfect results through these type of fixes, and we can get the analysis. So if I, per day approximately 500 or 1000 PCBs are tested, we can take the results of these PCBs on a single screen. And if you want to have the require the Excel file, we can have the Excel file of that. So let's open this fixture so we'll get an idea what is inside. Yeah, you can see wirings and lots of engineering and complex work here. So these are PLC which we have utilized. These are the relay modules which is going to be connected with the power supply, like mains current with the mains with the battery. It is going to connect and disconnect the load whenever it is required. So these are this type of wiring. This all things are done at MICROHUB inside only, and we are providing this type of solutions to lots of clients. Also we are getting lots of orders from the YouTube. So thank you guys for giving this much of orders from the YouTube also. So if you have any such kind of requirement and customized PCBA test solutions required, you can contact my group. Our one-stop solutions team will get back to you with the best out of the best solutions. And we are working in India as well as out of India. So thank you guys for watching us. Please keep in touch, like, share, and subscribe our channel, and please press the bell icon so you will get the notification from my group. Thank you guys for watching.